Oh yeah, what's up YouTube? This is Kosho at the Kosho 619. I want to go over some stuff today about tail rotors and what do I think about tail rotors and how do I get my tail rotor to hold and not to wag. I think that's my first question on people. They say, hey man, how did you get your tail so stable on that blade helicopter? And man, mine's got a wag and I don't know what to do. Well, some of us have been in this hobby so long that we've learned with mechanical gyros and things how a helicopter actually works, and what a helicopter is doing when it's starting to take off, and actually at all times, is when this blade is spinning. The blade is spinning clockwise, and what that does is make the helicopter want to spin to the left, the nose left, and your tail will go to the right. And as it's doing that, basically your gyro is having to try to compensate to hold the helicopter stable as the blade is turning. So the helicopter, is getting input basically from the gyro, which has, sensors in it basically to try to hold the helicopter straight. So, these helicopters were built in a factory. There's a whole bunch of people building them. They're totally inclined people, and they get your helicopter within realm of flying. So basically you could fly it this way, and a lot of people do, but if you want it perfect, what you want to look for, well, I didn't even get to it yet. Basically the helicopter needs some right pitch in the tail in order to hold itself straight in the air. So what right pitch is, the easy way to see it is to cross your rotor blades over and basically sight down them, and basically with the blade on the bottom pointed towards the boom would be an input of right pitch. And also a good thing to look for is the little bell crank here is pretty much 90 degrees on the tail shaft, and you've got even throw both ways, but you're going to have some right input. What this does is give it mechanical advantage, and the gyro doesn't have to work so hard basically, and it doesn't have to hunt for a position to hold. So basically what you're doing is giving it just enough right pitch to hold the helicopter straight so it's not drifting. What a wag is the helicopter hunting. It's trying to find where that position is. So every time it goes away from what its center is, from when you turned it on, it tries to push it back. So it's just constantly wagging because it's trying to find home. So what you've got to do is essentially go right here to this servo mount. These servo mounts are kind of loose already. They're plastic. What I do is basically, we're going to turn the helicopter here on in a second, but we look for this arm to be 90 degrees. If you can get it 90 degrees, as close as you can anyway. Better to be forward, not backward, or 90 degrees. 90 degrees is best. My servo horn is lengthened from stock on this one. I like a lot of input on my tail. You can do that. This gyro is adjustable on your DX radio or IX12, and it's starting from the beginning, you guys. You can't just really these do fly great out of the box, don't get me wrong, but if you want it to fly perfect, there's tuning involved, and some people are more picky than others, so you've got to tune it. We're looking for this to be centered. We're going to turn the helicopter on here in a second, right now. And this is what you're going to look for. I'm going to cross my blades just like I showed you. We're gonna cross them way over here like this. My radio's on. Have to have your radio on. We're gonna watch this tail, guys, as I plug this battery in correctly. Now, where did it set? So you're looking for this little gap right here between the tail. And that's me. You ask how to get my tail to quit from wagging and how to get so locked in. Any helicopter I fly, I look for that. So here's some right pitch. Also, with that lengthened servo horn, you want to make sure you have full throw. There's full throw. The servo's not binding. There's no noise here. We're going the other way. There's no binding. There's no noise there. Back and forth, no noise. Everything's clear. Also, you're going to look for a straight line here in this linkage. You want this linkage to be as straight as possible. None of these have a kink in them, so that that servo can move and do its thing as fast as it can, It's trying to hold your tail. So basically what you're doing when you adjust your PID gain, we're going to go into there right now. My helicopter's on hold. Let's go to model adjustment, forward programming. Here is my tail rotor. Come on, tail rotor. Maybe I didn't touch it enough. Tail rotor. You can turn up your pirouette rate. I turned mine up to 575. Let's see if I can get on this. And the start and stop gain is the same. My proportional is 80. My integral is 80, and my derivative is 92, and that's in hold mode. Let's get out of hold mode. You can with this helicopter. Here's normal mode. We've got 575 rotations per second, 25 and 100 start stop. You've got your proportional at 80, integral at 95, and 95 in normal mode. That's just what I came up with. And then here we're going to go into stunt mode. Stunt 1. You can switch stunt modes while you're in the programming, so you have to adjust where you're having your problem. So here's stunt 1. I'm at 80, 95, 95. My head speed doesn't change much. I'm able to pull off the same numbers. We're going to go stunt 2. And it's significantly lower. So here you are at 70, 90, and 95. I don't have any wag, and I'm able to do funnels and things without my tail blowing out, and it doesn't wag at all or make a weird noise or anything. So I think you saw in one of my videos when I was doing that before. So let's go back. The tail rotor, basically, I didn't have to adjust any endpoints with that longer servo horn. So as long as you've got that right pitch in your tail, you're not going to have any wag. I don't know where you're getting at. Make sure that everything's, you know, smooth and correct, and that's about all there is to it. You can go to setup, I believe it was, and here's swash plate setup. What I did was, I think you go to output. Oop, there's sub trim. That's how you get your servos level. This is all centered here. I'm trying to remember here. Button setup. Tail rotor setup though does have endpoints and output setup. So here's output on your tail rotor. You can do travel. Here's travel left and right, so you can get full throw, but mine's at 120 just like it is stock. I'm just going through the settings that are on here. There's a sub trim too. You can adjust that tail rotor, but I wouldn't put any sub trim in it. Do it mechanically, it's better. We're gonna go back here. It's tail rotor advanced setup. Actually, let's look at what tail rotor advanced setup is. I'll tell you. Advanced setup is the phasing, and that's basically don't adjust that number. You don't need to. If the helicopter's swash plate is out of straight with the tail rotor, you can adjust it. But that's something that we might deal with on a bigger helicopter, so not this one. My gain channel is inhibited. I think we can assign a gain channel, but we don't need to because we have the forward programming, and you can go into your tail rotor PID. So let's not worry about the tail rotor PID. Let's see here. Where am I at? Setup. Swash plate. AFR. What is AFR? That's how far the swash plate goes. Don't adjust those numbers. That's the pitch and the collective, the amount of range that they have. Trying to find something else here. It wasn't
20 seconds.
Here's agility. I put my agility back at 95. My pitch and roll though has changed. I've actually turned my rate up a whole bunch. 420 is what I'm using now on my seconds. I'm sorry about my timer. I don't know how to turn it off when I'm in the program.
Timer expired.
So you have to match the roll rate and the pitch rate. I do anyway. I mean, if you're going to do a piro flip, you want them to roll and pit and flip forward or backward the same. So 420 on that, on the degrees per second. And let's see, is it in the system setup? Well, don't calibrate the sensor. It's not in the system setup. Me on the output. Here's sub trimming your servos. These are done at the factory. You can set the servos straight. We're not going to deal with that right now because my helicopter flies fine.
-1 minute.
Oh, where is that? I'm trying to remember.
Hold.
Here's your safe and your stability. You can, I'm on hold mode right now. The safe is off. You can see it's off, the stability mode. If I go back to normal mode here and we let the hold off, you can see that my stability is on. So that's telling me that it's on in the switch position on flight mode here, that is forward. Don't set your radio to switch B, set it to flight mode. It does make a difference. I learned that myself the other day and it was unbeknownst to me, but it does make a difference. So as you can see, as I go into stunt 1 or stunt 2, the stability is off. You can turn it on in any of those modes, but you won't be able to flip over anymore. And, you know, that's pretty rough. So you may be able to turn it on once you're upside down, but I probably wouldn't do that. So here's my normal mode. Somewhere in here in the menu, I'm not sure where it is now. That's pitch and agility. Okay, there's a travel adjustment, and now I can't find it. It's got to be in setup, and setup on Swash plate and output. That's sub trim though. Output. What am I holding now? AFR. Maybe this is my collective. Let's see here. So you can turn up your, there it is. I'm in setup now, and I was looking for this. You can turn your pitch up and down. You can see my Swash plate being pulled more. I was at 70. I kept it even both ways. So here's 70 one way and 70 the other. What this does is give you more collective. If you don't have a pitch gauge, you're gonna need one. Let's go ahead and do it together, because I haven't done it on this helicopter yet. This one's made by Align. You can get it from any company. See if the thing goes back on. You put it, so basically what we're doing here is at center stick, you wanna verify that these blades are pointed or are flat basically. It's hard to show you because it needs to be on the table, so I don't want to adjust the camera, but you're looking for the blade to be flat. So let's put it on the table. Here it is. Blades are flat and we're at center stick. See, if I move it, the blades move. So center stick, hold mode on right now. You're gonna, I know the blades are flat because I've flown it. We're gonna put the pitch gauge on. and you're gonna hit 0, 0. Trying to get this on camera, guys. And now we're gonna go to the full range here. So here's 13.3. I want 13.5. 13.5 is get you good 3D. There's 13.9. Heck, why not? Let's just do. It's a small helicopter. I'm gonna put 14 degrees in it, guys. This is your preference. I do 13.5 to 14 on a small helicopter, and I fly 13 degrees on a big helicopter like a 700. So right now we've got 14 degrees, and then we're gonna go negative, and I've got 16, so we want to subtract from that until I have 14 degrees. So there's 13.8, and oh, there's 11.6. So it looks like it goes the same each way. Let's just take this to 13.8, and then there's 16.1. So I'll show you what I'm going to do. I'm going to go to travel adjustment, and we're going to adjust that. What else do I need to say before we do any of that? We're going to hit OK on this, and that's the collective, and we're going to go back here. So we're basically talking about the tail rotor. I went through all the tail rotor. You've got every setup, everything you're gonna freaking need is in here. And we're gonna go to, now we're gonna go to servo setup, and we're gonna go to endpoints. I think this is gonna work. I've been doing this so long, everybody, that I try things, so let's do it together. Since my pitch isn't correct, we're gonna go full pitch. We're at 13.9, and negative pitch is basically where this is at, and we're gonna subtract it. Okay, so now you can see that's there's 14.1 and 13.8. Let's just do 13.8. Take some out of my radio. I'm hitting minus 13.8, 13.8. Okay, so now we have equal pitch each way, everybody. And